Hi there, everyone, and welcome to this session in which we'll be discussing the Applied Machine Learning and Data Analyst programs. My name is Bertram Haskins, and I am the Program Manager for these programs. So what are we going to get up to today? Our agenda is we're first going to discover what data science is. Then we'll take a little bit of a look at the various program structures for applied machine learning and data analyst. Next up, we're going to briefly touch on what the job market is for these various programs. And then lastly, we will discuss the admission requirements for these programs. Right, so let's get going. So first off, right off the bat, what is data science and why do I mention data science? So I think the best person to tell us about this is probably someone or something that is on everyone's minds these days. And that is one of our large language model friends, in this case, ChatGPT. So let's say, what is data science? So you never know what you're going to get as an answer, but generally speaking, you will see that data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems, and its focus is on both structured and unstructured data. So anything that relates to data. But that encompasses a whole big wide variety of things, including analyzing data, mining data, performing predictive analytics, finding patterns in data, and performing machine learning. So now you might realize why I want to mention data science, because both applied machine learning and data analyst form part of the, let's call it the data science corner in the vocational school, along with Python for Finance, where I'm also the program manager. So we now know that data science sort of touches on a whole variety of things. So the first one of our programs that actually touches on this is applied machine learning. Now, machine learning is a subset of artificial intelligence, and it consists of various algorithms that can be applied to sort of imitate the way that humans learn. At its basis, at its fundamentals, it basically creates statistical models that allow us to do things such as classification, i.e., can the algorithm spot whether there is a cat wearing a hat in an image, or it can be used to do prediction. So if you're an avid runner and you have historical data of your past 5 years worth of runs, possibly it can predict how you'll do next week in the race. So why do we refer to it as being applied? So in applied machine learning, we do not start from scratch. We teach you a little bit about the background, but we actually use off-the-shelf components. So we do not focus as deeply on it as you would on a computer science course. So you will learn how to use ready-made components and then implement them using the Python programming language. So you might also guess that this means that throughout this program, you are going to learn to program in Python. You'll learn to work with data, how to process the data, and you'll also learn how to work from databases. So in essence, it covers a whole programming sphere along with machine learning concepts. Now, the structure of the program, it's broken up into 38 academic weeks. Now, within these 38 academic weeks, there are various courses that we'll cover. The first of which being problem-based learning, in which we do fundamental problem-solving skills, report writing, and we'll also, from August onwards, we're going to start touching on MySQL or SQL and databases as well. In Introduction to Programming, you learn how to program in Python because you'll use it for the rest of the course or all of the courses and the rest of the program. Introduction to Data Mining focuses on insights that you can get by analyzing data, not necessarily programmatically. In data pre-processing, we do the traditional things that you want to do in data analysis. We pull the data together, apart, we standardize the data, and we see what we can do with the data before we start feeding it into machine learning algorithms. Now, next up, we have programming for machine learning. Now, as part of preparing to perform machine learning, there are a wide variety of periphery things that you need to learn, such as which metrics work best for machine learning processes. How do we extract features from certain things? And then lastly, we have computational intelligence, which also allows us to think about the various different machine learning models that we can implement. And we do a wide variety of different model implementations. Lastly, then, we learn how to visualize our insights using Python and the Matplotlib library. When we're done with all of this, you will complete an exam project. This part is quite exciting because you can actually choose an exam project that you want to work on, something that piques your interest. Now, next up, we have Data Analyst. Now, where applied machine learning focuses on, we take the data and then we construct machine learning models of it. Data Analyst delves down a little bit deeper into the actual data aspects. So it's concerned more with the cleaning, inspecting, transforming, and modeling of the data, with the idea that we want to suggest conclusions and support decision making. Now, in Data Analyst 1, we are very much focused on teaching you the fundamental aspects of data analysis. So in other words, you learn the jargon so that if one day you stand around the water cooler talking at your workplace, you know what the fundamental terminology is. So in Data Analyst 1, we focused on using spreadsheet-based tools such as Microsoft Excel to teach exploratory data analysis, or EDAs. We're also focused on reporting and visualization. Now, both for Applied Machine Learning, or AML, and Data Analyst 1, also called DA1, the output, once you finish, is a professional degree. Now, Data Analyst also has an optional second year. You can sign up for the second year later, or you can sign up for Data Analyst as a whole for year 1 and 2. Now, the second year is more focused on taking the bits that you learned, the fundamentals that you learned in Data Analyst 1, and then evolving it by adding programming and cloud-based tools. So Data Analyst 1 takes these concepts and then starts to introduce extra languages and technologies such as MySQL, Python, Microsoft Azure, and Power BI. Now, the program structure for DA1 is broken up as follows. DA1 is also 7 courses over 39 academic weeks. In data analysis and fundamentals and data-driven decision-making, we basically teach you the fundamental aspects of working with data, the theoretical insights. Spreadsheet fundamentals takes you from 0 to hero with regards to the basics of using spreadsheets, because we cannot assume that you're already able to use spreadsheets when you walk into the program. In statistical tools, we build on further concepts with regards to data analysis, but we also teach you further functions in Excel that will aid you, or in various spreadsheet software, actually, that will aid you in your analysis. In evaluation of outcomes, we build on your analysis knowledge a little bit further, but in this very lengthy course, we also focus on various scenarios. In other words, what are the various ways in which you can apply the knowledge that you have learned throughout the program. Now, we also then have data visualization, in which we focus on creating visualizations using spreadsheet tools, but also a few tools that we can use to design graphical elements with. And lastly, we have analysis reporting, in which you learn how to communicate your results to your audience, which is a big part of the data analysis process. For data analysis 2, we basically have at the end of it, or sorry, at Data Analyst and Analyst 1, at the end of it, we have a semester project or in the middle of it, we have a semester project, and at the end of it, we have an exam project. Both of these projects basically take a look at what you have done up to that point. So it basically tests your skills to give you a little bit of insight as to where you are at with regards to the content that you've covered. Now, Data Analyst 2, which follows on Data Analyst 1, is also 39 academic weeks. It starts off with databases and cloud services, in which you will learn a little bit about using database tools. You'll learn about using MySQL and how to connect to online databases. Programming fundamentals, we go through the basic fundamentals of Python programming. In programming or in programmatic data analysis, we build on that and teach you how to visualize programmatically. Then in industry tools, we use a few ready-built tools such as Power BI, and you get your first real introduction into Microsoft Azure. And then critical data thinking takes you back a step. It lets you think about the other types of characteristics about data. So what are the ethical things that you need to consider? What do you need to consider with regards to GDPR? Then we have big data and advanced topics, in which we touch on big data and how to use online tools to set up online data repositories. And we also touch on basic machine learning, basic linear regression, and a few other techniques in which you can do it locally or you can do it online in a no-code based environment. And then lastly, we finish off with interactive dashboards, where you learn to put all of this together in a format that the user or your stakeholders can review in an interactive format. In the middle of the program, there is a semester project which will test your skills in databases and cloud services, programming fundamentals, and programmatic data analysis. And then you also have an exam project at the end of it that tests all of your skills. Let's quickly discuss the job market. For AML, you can wind up being something like a junior machine learning engineer with the skills that you will learn throughout all of the courses, because you'll program everywhere, and you will also start learning a little bit about SQL coming from August onwards. You will be able to be a junior software developer. If you already have an existing qualification, such as an engineering or science or marketing qualification, you can also use the skills that you learn in applied machine learning to augment what you're already doing, making yourself more marketable. And then you can do a little bit of freelance consulting. Now, to be honest, the freelance consulting and the augmentation of existing skills actually applies to AML, DA1, and DA2. With DA1 specifically, you can become a data analyst with a focus on working in spreadsheet technology. Data analyst, it's a very broad term, because you can become a data analyst for marketing data, for financial data, for sales data, for medical data. So it's a very all-encompassing term. And the Data Analyst 2 job market just takes this a step further, where you can do all the same things, but with a focus on programming and cloud-based tools. So lastly, what are the admission requirements? There are no special admission requirements either for data analyst or for applied machine learning. Basically, you just need to have your Norwegian upper secondary or higher education entrance qualification, and that should be okay. There's just one catch. If you want to proceed into Data Analyst 2, then you need to go over you first need to obviously complete Data Analyst 1. And that brings us to the end of the presentation. So the world of data, it's everywhere with us, whether it is data analysis or taking it a step further and building machine learning models. Everything these days that you tend to think of as AI is most probably just a machine learning model. So the world of data analysis and machine learning is really permeating into every aspect of your daily life. So I think it's probably a good idea to get a head start and join us on the data revolution. So thank you for joining me. And if you have any questions, feel free to post them in the YouTube chat. I'm going to see if we already have any questions. Let me just stop sharing my screen and I'll turn to the questions. Okay, so the first one. Do you have any examples or projects or assignments that students are given during the programs? There's a multitude of ones depending on which program we are referring to. So say, for instance, if you're doing machine learning, as an example project, you could do things such as solving, I don't know if any of you have ever noticed, there is a worldwide competition where you can have a mouse run, a robotic mouse run through a maze. Now that is an optimization problem. So one of the examples projects that you could be given in AML is actually you're given a little maze, and then you have to optimize how a character runs through a maze, because those same principles apply to optimizing processes. Now, you might have seen the example that I had for applied machine learning where there was a little path that was being optimized. That is actually one of the things that we can use as an example in machine learning, where you learn about using a genetic algorithm, which is also part of optimizing things. For data analysis, there's also a multitude of things. You would be given an example data set, say for instance, and you would be asked to pull out EDAs, to form insights from the data, and then go and write down these insights, report on them. As part of your reporting skills, you will also that is enticing. What are the things people like to look at, and then how to use tools to make it informative and interesting. So next up, how do you stay updated with industry trends and adapt the program to reflect these changes? Yes, that's a good question. So what we do have is we have meetings with industry. We actually have one scheduled for next week as well. So in those meetings, we do meet with people who could actually provide us with a little bit of insight and feedback on the current state of the study plan and on the current state of what we actually present in the courses. And then we use those insights to actually refresh the courses when necessary. So an overview of a typical student profile that thrives in these programs. I've been in education at various levels for many years, and that is actually that's a tricky question, because everyone is different. There's no standard profile for someone to perform in any given program. That's the unfortunate truth. So it's rather a common question, as in, what should a student be doing? Any student who is diligent, whether it is in machine learning or whether it is in data analyst, the student who actually commits to the work and diligently follows through with all the lesson tasks and activities, and very importantly, at least to me, the student that engages not only with the teachers. Engaging with teachers, it's good, but I think the main thing to engage with is the other students in the program, building those lifelong connections and getting insights from others with you on the same program. So in essence, the strengths that all of the different personalities bring to the program and the chats that the students have, that makes it so that there is no specific profile. In fact, all of these different variations and people who join the program actually strengthen you as a student overall. Who is the data program suitable for, and who is the machine learning program best suited for? Again, it's very difficult, but let me put it this way. If you want to go with data analyst, you would be the person who wants to work a lot specifically with the data itself. So in other words, you want to, even if you go into data analyst 2, even when I perform data analysis, initial analysis, if I want to create machine learning models, I look at the data beforehand first to see what kind of data I have, how can I modify the data, or how should I format the data, rather is a better way to say it. So the data analyst aspect would be someone who enjoys that aspect of it more, who thinks they can do great insights from the data, they want to work with it, they're going to work with people, with the stakeholders, figure out what's going on in the data, and then personally do the reporting. Whereas machine learning, it tends to be the person who either already has a skill that they want to develop further, or it's someone who wants to be more on the programming side of it. Because although you will work with the data, you will also still process it, you will not actually do individual manipulations using functions in a spreadsheet on the data. You will be the person who likes writing code separately, and then the code does the manipulation for you and creates the models for you. How is the contact with teachers and fellow students as an online student? To be honest, that depends on the student. We really want to get the student involvement. We recommend students use their online channels to communicate with the others, communicate with the teachers, share things that they find interesting even. But at the end of it, that comes down to the students. As I always tell any student who starts a program, you have to remember that teachers they're fantastic. You will meet them. They will be helpful in everything while you are on the program. But 1 or 2 years down the line, the teachers probably are not going to be the people you still have contact with. So I always tell my students, when you start a program, make a commitment. Speak to the other people online in the program with you. Try to get them to know them as a real person, because I truly believe that the relationships you build up in any of our study programs, they are the ones that will follow you for the rest of your life. They are the ones that will open doors for you in future, because they are the connections through which you will learn more about the industry and openings in the industry. So we really support and try to get people to communicate in the online platforms to try and get them to be a student community. But at the end of it, it comes down to the student preference, whether they want to do it or not. Let's see here. I don't see anything else. We still have a few minutes, so if you have any other questions, feel free to pop them in the YouTube chat. Yep. Seems that's it. Thank you, everyone. I'm glad you managed to join us today. I hope you enjoyed the session, and I really hope we'll be seeing you in one of our data science related programs in Noroff Vocational School. Thank you, everyone. Have a nice day further. Bye.